So the lesson we are going to do today is 3.2 families of graphs. So that. All right. So the first thing we're going to do is show what each graph will look like. And we'll start with a linear graph. And with that, it's going to look like that. Minus this little space missing. And this is a very common linear graph that you can do. And what it'll look like is x. And that is what this graph represents here. For the domain of this graph, you're going to find you can reach for negative infinity and positive infinity. For the range, same exact thing, you have from negative infinity and positive infinity. If for when finding the maximum minimum, how the behaviors as x approaches infinity, y approaches infinity. And it's the same thing for the bottom part. As x approaches negative infinity, y approaches negative infinity. All right. And that is the linear function. So our next one is going to be absolute values. And what an absolute value function looks like is this. All right, and what this graph represents right here is y equals the absolute value of x. So the domains you can find for this one is anywhere reaching from negative infinity all the way to infinity. The range you can find for an absolute value graph is from 0 all the way to infinity. And that's because anything inside an absolute value is going to be positive. So as you can see here, it only reaches 0. It will never go under that point. And for the end behaviors of this, you get as x approaches infinity, that's terrible. Y will approach infinity as well. And as x approaches negative infinity, y will approach infinity. All right. Next one we have are radicals. And as soon as I get done racing here, I'll show you in a sec. Alright, and so a radical function looks something like this. And what this graph represents right here is y equals the square root of x. And the domain for this is 0 all the way to infinity. The range is also 0 all the way to infinity. All right, and the end behaviors you can find for radicals is as x approaches infinity, y approaches infinity. And you can't have negative infinities because obviously it starts right there. It can't go below to quadrants 3 and 4. So the next one we have is the quadratic. All right, and the quadratic is something like this. All right, and the quadratic represented here is y equals x squared. And the domain and range for this one is d negative infinity and infinity. As you can see, it goes all the way that way, all the way this way. Range only to 0 and infinity. Because obviously you can see right here, it stops right there. Just like the last one, it won't go to quadrants 3 and 4. And the end behaviors you have for this one is as x approaches infinity, y approaches infinity. And as x approaches negative infinity, y also approaches negative infinity. What happened?
Put your pen back up there.
Oh, that's weird. Okay.
Drag it off the screen.
There we go. All right. The next graph we'll be showing is the cubic, and it looks like this. Right, and the cubic represented here, roughly, is y equals x cubed. All right, and the domain for this is negative infinity all the way to infinity. You can see it can go this way all the way, and that way all the way. The range, excuse me, you have nope, that's so wrong. Negative infinity, saved it, and infinity. All right, and as you can see, it goes all the way down, and it goes all the way up. So the end behavior you have for this type of graph is as x approaches infinity, y also approaches infinity. And as x approaches negative infinity, you have the same thing as y approaches negative infinity. Oh. And the next graph I'll show is the cubic root. The cubic root looks something like this, but as a whole. There we go. All right. So what this graph roughly is the opposite or the inverse of a cubic, and that will look like the cubed root of x. And so what that looks like for the domain is all the way from negative infinity to positive infinity. And the range, same thing. You got negative infinity and positive infinity. The solution for that is the end behavior. So x approaches infinity, y approaches infinity. And x approaches negative infinity, y will approach negative infinity. Alright. Now for the next one, you have a greatest integer, which is for a step graph, which has a terrible drawing right here, but it'll look like this, and it just keeps going like that. And the one shown here is y equal bracket x bracket. The main for this graph is negative infinity and infinity. Obviously, you can go this way and this way, and the range is the same thing. It goes negative infinity and into infinity. All right, the behavior that you can see for this graph is as x approaches infinity, y approaches infinity. And then as x approaches negative infinity, y also approaches negative infinity. All right. And the last graph I have to show is called a constant graph, and it looks like this. All right, what we have seen as is y equals c, or in this case on the graph, what it shows is 3. And basically, the domain inclined to this is negative infinity all the way to infinity. And then the range inclined to this is B, C, or C. Just for this graph only. Now, if I had it the other way, where say it was just x equals 3, then you would have these flips. Alright, so anyways, the end behavior you get for this is as x approaches infinity, y will C. Y will approach C. And as x approaches negative infinity, y approaches C. Alright, and that is it for family graphs. Alright, how do I stop it?